few topics in HANA database. So in HANA, so we have some small topics like, so we would like to discuss about the resident HDB LCM, resident HDB LCM. Normally we have the one HDB LCM. We will use it for the installation of the HANA systems and updating the HANA systems. We will use the resident HDB LCM, right? Resident normal HDB LCM. So there is a one more HDB LCM will be created after the installation. So if you see in the system, HANA system, we go to /HANA shared, there is a one SID will be created, S4H, right? Under this we have the HDB LCM, right? There is a one folder. So profiles we know, global directory we know, HDB instance number we know, exe we know, but the resident HDB LCM, this is one of the frequently asked question during the interview point of time. Frequently they may ask you the questions. So what is mean by HDB, resident HDB LCM? So normal HDB LCM and resident HDB LCM. So normal HDB LCM means we can use for the installations, upgrading the component and everything, right? So resident HDB LCM. So this is the resident HDB LCM. So this is used to perform the post installation activities. Post installation activities means this is used to perform the post configuration. After the installation, again you need to download it. So this will be installed. This will be available under /HANA shared SID and HDB LCM. So this is the location of the resident HDB LCM. So after the installation, you will get this resident HDB LCM. So using this one, so we have to execute this through router, through root user. Suppose using this one, then we can execute now //nadb, you will get the usage. So what we can do with this one? So we can rename our HANA system. You don't need to uninstall it. You can just rename it, uninstall, unregister, updating, SLD configurations, all type of things we can perform using resident HDB LCM. Resident HDB LCM. This is the resident HDB LCM. Okay. So anything like after the installation, you want to add the system, you want to add additional host. So then you can click so during the installation, do you want to add the host? You missed that one. That time you don't have any requirement. So now you have the requirement. Then in this case, just you can click it. Then you can add the other host to this system. It kind of scale out scenario, scale in, scale out scenario, right? So no, you don't want to do that one. You want check the installations. So you just will cross check whether the install is fully completed or not. You want to configure the SLD. So few times normally we will use this one. Why? Because in every landscape there is one separate system we will install it. So SLD, system landscape directory in SAP product, so that all the systems can be registered into that system. So that will be reported into that system, so that it will be easily for the tracking and configuration purpose. So we will use the SLD system here, right? So here we don't have SLD. If you have SLD, then you can keep the SLD to go on 5, index number 5. You can do the configuration of the SLD. You want to update your HANA database system. So normally we will download it, we will update it. Suppose you want to update it, here also you can update it. Enter the directory to update it. Here also we can do the update here, right? So this type of things we can do using the resident HDB LCM. You want to configure the SLD, you want to print the components. So all kind of post activities. So after the installation, whatever you want to do, you can update the post configurations. So suppose you want to unregister, you want to uninstall, you want to rename. Suppose you want to rename it. Suppose like I want to rename this S4H system to, so you don't need to uninstall it again. So just you want to rename it to some other databases, some other databases. So suppose if you have the target system also, if you are changing, then you can change the target host name also. If you want to change the type, you can change the type also. So whatever, if you want to anything, password, SID. So what SID you are going to change it. So then everything we can do via here. So suppose you want to change, so enter the SID S4H to S4P, then you can change it. So that is the thing. So you can change it. So which means you want to change S4H to S4SID. So this target SID. The data will not be deleted. Just so only system, the rename will be happening. So same in SAP level, how we done for using the HDBL normal SWPM, same way we can perform it. So target instance number, suppose we want to change the instance number 00 to 10, we can update that 10. So like that, so we can change the, like that we can change the, all these things, everything we can change it, we can change it. So this is the way. So anything like you want to update the configuration, so you want to configure the SLD, so you want to register the system to anything, like after the installation you want to do any post activities, you can perform using this resident hdb lcm. So resident hdb lcm is the one of the tool which you can use it for configuration of the post configuration related activities in the system, post configurations. Okay, so that is the resident hdb lcm. Okay, got it. So normal hdb lcm we have, that is for the installations, right? You can do the installations, upgrade, so all kind of uninstallations also you can do. Suppose every time you no need to download the patches and everything, we don't need to do that one. So when you have the resident HDB LCM, so you can also plan the all these activities, you can plan it, all these activities you can plan it using this resident HDB LCM. Okay, so any questions on this one, resident HDB LCM?
Hello.
Yes, yes, no,
Yeah. Sir, if you want to change the name, right, using resident HDBLC.
yes, yes.
So, for example, we have the SAP HANA host machine. So we
Yes.
can change it to SAP Linux one.
Yeah. So you have to.
What
Yeah, we
about
can.
the data? What
Data
about
will
the
be
data?
data will be there. Data will not be deleted. That is the reason we are using this one. Suppose if you want to install the new one, suppose your host name is changed, something is changed. If you want to install the new one, so then that again data will be deleted. Why? Because you need to uninstall and again install it. So if you rename it, the data will not be deleted, right? Data will not be. If you rename it any file, the data will not be deleted. It will be the same, right? So that's the reason. Suppose if I rename it this file, data will be the same. Data will be the
No,
same.
no,
Just
that's fine, sir. My question is different. See, that is fine. The folder rename or file rename is fine. But whatever, for example, SAP HANA is one of the Linux machine, right? One of the OS, DBOS. So if
SAP
we want to,
SAP HANA is not the OS. SAP HANA is the one of the database we are installing on top of. So one Linux machine we are installing.
so Linux machine name is, it is SAP HANA, right here?
Yeah, that is the machine name. Yes.
Yeah, machine name. That's what I'm telling, sir. So we can change it to DB Linux OS to other name from the existing.
Yeah, we can change it actually. So if you see here, there is a
But
configuration.
what about the data, sir? I mean to
Data
say, what about the system DB and tenant DB?
data will not be deleted. That is the reason SAP provided this option to reconfiguration. Data will not be deleted. Data will be the same. Data will be not done. Just only maybe SID you want to change it, you can change it. Maybe host name you are changing, you can change it. So data will be the same. Suppose now
Sir,
our host name
you
is
mean to say the data will be copied or it just remains same only?
remains
It
same.
will
Date,
copy in SAP Linux one also, the same system DB tenant DB. Is that possible?
you mean to say okay, this host name is changed, right? You mean to say this host
Yes,
name
sir.
is
Yes,
changed
sir.
to the SAP HANA 1. Okay, it's
Yeah,
changed to the
okay.
SAP HANA 1. So
if we have existing Linux only, right? If we have existing Linux only, we can change that.
yes, existing only. Why? Because this database is installed on the, so this database, this HANA database S4H is installed on the this SAP HANA host name, right?
Correct, sir.
So
Correct.
tomorrow you changed this one to the SAP HANA 1. You change it to the
Okay.
SAP HANA 1, but HANA it won't start it. Why? Because previously it was installed on the, so SAP HANA. Now you want to change it. How means using the resident DBLCM, you can update the host. You can update the, you can rename it. While renaming, so it will ask the provide the, here it is asking the provide the target HANA server. Like then in this case SAP HANA 1, you can mention it. That will be, so just you mention it, that will be changed wherever the configuration HANA side configuration files so mentioned as SAP HANA, that will be changed to the SAP HANA 1. So data will be the same. Data will not be deleted. Data will be the same.
సార్ తెలుగులో అడుగుతా సార్, నో ప్రాబ్లం. ఇది ఏం లేదు సార్, ఇప్పుడు ఎస్ఏపి హానా లైనక్స్ డిబి లైనక్స్ ఓఎస్ ఉంది కదా, సో దీంట్లో ఉన్న సిస్టమ్ డిబి 10 డిబి మనం చేంజ్ చేయాలనుకుంటే హోస్ట్ నేమ్ ఎస్ఏపి హానా 1కి, సో అప్పుడు ఈ సిస్టమ్ డిబి ఈ 10 డిబి సేమ్ కాపీ అవుతుందా సార్ ఎస్ఏపి హానా 1కి, లేకుంటే
కాపీ
ఎలా
అవుతుంది.
ఎలా
అదే కదా చెప్తున్నా, అదే చేంజ్ అవుతుంది కదా, అదే చెప్తున్నాను కదా నీకు నవీన్. ఎస్ఐపి హనా ఉంది, ఎస్ఐపి హనా ఉంటుంది, ఎస్ఐపి హనా ఉంది ఇక్కడ హోస్ట్ నేమ్, ఎస్ఐపి హనా హోస్ట్ నేమ్ ఉంది. దట్ యూ చేంజ్ ఇట్ టు ది ఎస్ఐపి హనా 1. ఓకే, యూ చేంజ్ ఇట్ ద లైనక్స్ హోస్ట్ నేమ్. ఓకే,
ఓకే,
you changed the host name to SAP HANA 1 in the Linux machine. Okay, so your manager or customer told that don't give it the SAP HANA 1, change it to the SAP HANA 1. Okay, something like HANA 1. Okay, you changed it. You changed it. After you changes, will HANA will start? Won't start. Why? Because previously HANA installed on, where it is installed? SAP HANA 1. HANA installed means, HANA means combination of the system DB plus tenant DB, whatever the databases are there. So it's system DB and tenant DB. Why? Because all the configuration, everything is pointing to the SAP HANA only. So now you need to rename the, so everything you need to rename it after the changes of this one. You need to rename it. For that one, నువ్వు rename చేయాలి. దానికి ఏం చేయాలి? నువ్వు go to the resident HDBLCM. Go to the resident HDBLCM. So go to the resident HDBLCM. Here ఇక్కడ మీరు చూస్తే రీనేమ్ ఉంటుంది, రీనేమ్ ఆప్షన్ ఉంటుంది. ఓకే, రీనేమ్ ద సిస్టమ్ 9 రీనేమ్ ఇస్తావు కదా. ఇక్కడ రీనేమ్ ఇచ్చేటప్పుడు ఏం చేస్తావు అంటే ఇక్కడ, సో ఇక్కడ టార్గెట్ ఎంటర్ ద టార్గెట్ హనా సోర్స్ హోస్ట్ అని అడుగుతుంది. అప్పుడు ఏం చేయాలి మనం? ఇక్కడ SAP 1 అని ఇస్తావు. హనా 1 అని ఇస్తే ఏమవుతుందంటే ఇప్పుడు ప్రజెంట్ ఉన్న కాన్ఫిగరేషన్ లో ఏదైతే SAP హనాకి పాయింట్ అవుట్ చేస్తుందో ఆ కాన్ఫిగరేషన్ మొత్తం SAP హనా 1 కి చేంజ్ అవుతుంది అనమాట. హనా 1 కి చేంజ్ అవుతుంది అనమాట. సో
అంటే చేంజ్ అంటే మూవ్ అవుతుందా సార్ మొత్తం కంప్లీట్ గా? అప్పుడు ఇక్కడ ఉండదు కదా
డేటా, ఇదే హోస్ట్ లోనే ఉంటుంది డేటా. ఎందుకంటే ఇది ఈ హోస్ట్, ఇదే హోస్ట్ లో నీకు డేటా మొత్తం సో చేంజ్ అయిపోయింది కదా. నీకు ఇదే హోస్ట్ లో ఈ హోస్ట్ నేమ్ చేంజ్ అయిపోయింది కదా. నీకు కరెంట్ ఉన్న హోస్ట్ నేమ్ నీకు చేంజ్ అయిపోయింది కదా. SAP హనా నుంచి SAP హనా 1 కి చేంజ్ అయిపోయింది కదా. యూ హ్యావ్ నాట్ ఇన్స్టాల్డ్.
అదే అర్థమైంది సార్. ఒక్కటే నా డౌట్ ఏంటంటే, ఇప్పుడు SAP హానాలో ఆల్రెడీ కాన్ఫిగరేషన్ ఉంది కదా మనకి, సిస్టమ్ డిబి 10 డిబి ఉంది. మనం చేంజ్ చేయాలనుకుంటున్నాం హోస్ట్ నేమ్. ఫర్ ఎగ్జాంపుల్ SAP హానా నుంచి SAP,
ఇక్కడ 2 థింగ్స్ ఉన్నాయి నవీన్. హోస్ట్ నేమ్ చేంజ్ చేస్తున్నాం, జస్ట్ ఉన్నదాన్నే చేంజ్ చేస్తున్నాం, లేదా కొత్తదాన్ని ఇన్స్టాల్ చేయటం. కొత్తదాన్ని ఇన్స్టాల్ చేస్తాం. మనం ఇక్కడ కొత్తదాన్ని ఇన్స్టాల్ చేయట్లేదు. కొత్తదాన్ని ఇన్స్టాల్
చేంజ్ చేస్తున్నాం మనం. ఇక్కడ
ఉన్నదాన్నే SAP హనా నుంచి జస్ట్ SAP హనాకి పెడుతున్నాం ఇక్కడ.
అదే సార్, ఇప్పుడు మన సిస్టమ్ డిబి 10 డిబి అవంతా టేబుల్స్ అవన్నీ ఎక్కడికి వెళ్తాయి సార్? హనా 1 కి వచ్చేస్తాయి అవి?
అదే డేటా మొత్తం అదే చెప్తున్నాను. కాన్ఫిగరేషన్ ఏదైతే ఉందో, కాన్ఫిగరేషన్ ఏదైతే హనాకి పాయింట్ అవుట్ అవుతుందో ఆ కాన్ఫిగరేషన్ మొత్తం SAP హనా నుంచి SAP హనా 1 కి చేంజ్ అయిపోతుంది.
అప్పుడు SAP హనాలో అసలు డేటా ఏమి ఉండదు ఇంకా.
అసలు ఇంకా హనాలో డేటా, ఇంకా హనా మీద ఏ డేటా కాన్ఫిగరేషన్ ఉండదు. ఉండదు.
అదే సార్, అంతే.
ఏ కాన్ఫిగరేషన్ ఉండదు ఇక నీకు. ఎందుకంటే మనం చేంజ్ చేస్తున్నాం కాబట్టి నీకు ఉన్న సిస్టమ్ లో ఏ కాన్ఫిగరేషన్ లో దీనికి పాయింట్అవుట్ చేయదు. ఇక అన్ని దీనికే పాయింట్అవుట్ చేస్తాయి. అన్ని దీనికే పాయింట్అవుట్ చేస్తాయి అనమాట. హనా 1 కే పాయింట్అవుట్ చేస్తాయి. హనా 1 కే పాయింట్అవుట్ చేస్తాయి. కావాలంటే లెట్స్ టెస్ట్ ఇట్ నౌ, టెస్ట్ చేయాలంటే ఇప్పుడు దీన్ని చేంజ్ చేయాలి. సో ఎస్ఏపి హనా వన్ చేంజ్ చేసి దీన్ని రీస్టార్ట్ చేసి ఉన్న డేటాబేస్ ని రీనేమ్ చేస్తే అప్పుడు మీకు తెలిసిపోద్ది. అప్పుడు మన ఆనా స్టూడియోలో కూడా వీ హ్యావ్ టు కనెక్ట్ విత్ ఎస్ఏపి హనా వన్ కనెక్ట్ కావాలి. అన్ని హనా స్టూడియోస్ ఎవరెవరైతే కనెక్ట్ అవుతున్నారో వాళ్ళందరూ ద హోస్ట్ నేమ్ దే హ్యావ్ టు చేంజ్ ఇట్ టు ది ఎస్ఏపి హనా వన్.
Okay, sir. No, thank you, sir.
Okay, so this is a resident HDB. Normally, so no one use this one. Only one option they will use it. Why? Because if you change the host name, so again you have to remap whatever the connections are pointing to the HANA database. You have to inform to the all the users, all the systems. You have to repoint it, right? Till the risky. So not sure which connections are talking to the HANA SAP HANA system. So normally in the real time, no one will use this concept. But so only rare cases. So the wrongly you put the name like SAP HANA. You already installed the HANA database. Data already exists. Some data already users created. Now how? So if you change the host name, HANA won't start. Then how? Then you can rename the system. You can rename it to the from SAP HANA to SAP HANA. You can rename it so that the all the configuration will be changed. The data will be the same. You can connect it. That will be the possible option. If you want to uninstall, you can do the uninstall as well. So whatever, if you want to configure this, normally this option will be used actually in the real time. Because in the real time in SAP side, SLD will be created. SLD application server will be created so that this option will be used to configure the SLD. Means our HANA system we will register into the SLD system. That's why this option will be used here. Okay, this is about the resident HDB LCM. Okay, so the next one which we are talking about the partitions. Okay, HANA partitioning. SAP HANA partitioning. Okay, partitioning. What is meant by partition? Suppose if you take example, if you have our house, in our house we will do the normal partitioning, right? Partitioning. Suppose our house is very big. So in that case, what we will do? We will do the partition. Partition means we will split it, right? We will split like something like that. We will split the rooms and so kitchen, something like that. We will split. This is hall. This is so something like that. We are splitting the our house, 150 square yards house. We are splitting like partitioning. So partitioning we are doing here, partitioning. So we are doing here. Same like that. So SAP, same like that. SAP also we have, so we have some partitions concept in SAP. SAP level also we have the some partition. SAP HANA, we have the partitioning concept here. So what does it mean partitioning? So which means so this feature which is introduced in the HANA database, the tables in the system, the tables, okay, column store tables, why? Because data will be stored into the column store tables. In the data will be stored into the column store tables. So when you are doing this partitioning, we can split the column store tables into so partitions wise, means small records. We can split the tables into we can break down the tables, we can break down the table records into smaller tables. In this way, so you can easily get the records. You can easily get the records from the tables. Suppose like, so why we have to split it? Suppose example, if you see, this is the one of the finance table, FICO table. So this table has so more than, suppose as per SAP HANA recommendations, if the table has more than 2 billion records, more than 2 billion records, then you need to perform partition. You need to perform the partition, which means it will create the one more table, one more sub table it will create it, which means this table has suppose 5 billion records. This table has 5 billion records. Okay, this table has 5 billion records. Suppose if any query comes to the database level, if we searching in the 5 billion records, suppose the query is coming to the one query is coming from SAP level to So what database level, one table. This is the one of the finance table. So this table records are the 5 billion records. So here the query should search the maybe employee number, should search the employee ID equals to 1 2 3 4 5. It should search it. So but here you have the 5 billion records. So it may take some time. Why? Because the data is the very large table, very huge table. So it may take some time to get the who are having employee ID 1 2 3 4, those details should be displayed. It should be displayed. So but that should be displayed. So but here the data size is very huge in the HANA. So in this case it may take some time. It may take some time, maybe minutes. It may take some minutes to pull the data from the database level. But because the table size is very huge. So for this type of tables, HANA introduced the one feature is called the partition, which means the table which are having more than 2 billion records, we can do the partition, which means we can split this 2 billion records, we can split to this 2 billion records into one more table, we can split it, which means we can split into the one more table. Why? Because more than 2 billion, like 2 billion 1 to again 2 billions, it will come to this table, right? Again it will split to the one more table. So like that, so it will split the partitions wise, data will be splitted here, so that when you are splitting the query comes, so it will check in the 2 billion records, nothing exists, then it will go to the one more table. If nothing exists, it will go to this one, nothing exists, yes it is exist, then immediately you will get the results here. Here not only one thread here, the query executing in the database means, in the delta storage means, it will check in the all the partitions, whatever the partitions we have, it will check in the three partitions, in the three threads it will be initiated. The query, it will initiate the three threads in the each partition, it will initiate the three threads, so that three threads it will be initiated. When the query, immediately the response comes, immediately the response will give back to the user. So instead of setting in one table 5 billion records, it may take time. But if you split into the tables into the three partitions, smaller records, small tables, though that, so the search results, the query searching, getting the response is very high. The getting the response is very here. The getting response is very high in the here. So that's the reason. So that is the reason the searching the results is very huge here, which means immediately you will get the data from, immediately you will get the so data. Okay, that is the reason Anna introduced this partition. Anna introduced this partition. Anna introduced this partitions concept. But we have here types of partitions are there. There are the different types of partitions supported by the Anna. Okay, now you know the thumb rule. Restrictions means the table which are having more than 2 billion records, we can do the more than having 2 billion records, we can do the partitions, we can do the partitions. Okay, so Hana, how many types of partitions we have? How many types of partitions we have? So if I talk about the so different types of partitions. So one is the different types of partitioning. One is the so hash partitioning, hash partitioning. The second one is the so round robin partition. So round robin. So hash partition and round robin partition. So here, if you go to the HANA Studio, here, so let me open the HANA Studio to show you the partition where we can do the partitions. Why? Because here three ways, like either the HANA Studio, HANA cockpit level, or HANA Studio level, or in the HANA SQL prompts, and using the SQL prompts also we can do the partitions. Okay, so hash partition, round robin, and range partitions. Yes, one more partition is the range partitions. There is the three types of partitions are there here in the HANA. So hash partition, round robin partition, range partition. So depends upon the your system environment. Suppose if it is the scale out environment or scale up environment, we have to do the these partitions. So here, so connect to the system here. Okay, I connected to the HANA system here. So maybe connect to the system DB as well. Segment DB as well. 00 partition tenant S4H. So, okay, so this is our HANA system. We know, like you are able to connect to the systems now, right? So here tables are available under catalog, right? Tables are available under catalog. Under the catalog, we have the schemas, right? Under the catalog, we have the schemas. So then, so select this one, select it. So select it here, go to tables and show distribution. So distribution, select this one, show the table distribution. So table distribution, you have the option. You can see either under the catalog, right click, you can go for the table distribution, or tables, right click and go to the tables distribution. So either way you can go for this one. You will get the one prompt here. So maybe catalog, we will search it out. Catalog, well, because we need SAP tables, right? We need tables. But here our data is very less. Maybe which table we may get? Huge size tables. Let's see the table name here. Maybe which table we will pick up. Yeah. Because the table size should be the more than 2 billion records. Okay, 2 billion records. Maybe so here how many entries are there? We can see here. Okay, 200 entries only. So which one will have huge size data? What about this one? This is also source. What about this one? This is also. Okay, okay, not a problem. We can do this one as well, but there is no effective actually. Why? Because data size is very less, right? We can do that one. It's not a problem. So what we can do here? So what we can do? Right click on the table. So right click, not here. CS columns, right? Table name is the CS columns. That is the table name. CS columns. CS columns. This is the table name. Just remember, normally as part of the EWA, you will get the recommendations. This column size is very huge. So to the partitioning of this system like that, so you will get the symptoms here, right? So that's the reason. So here you are not getting anything here. But let's find out the here. Let me try to find out. Are there any other tables? Is there only one entry is there here? Basically what I am doing here, so here I'm trying to find out the table, which table has so more than more than records. At least here the less number also, that is fine, but we can take it whatever the tables we have here. It is displaying, nothing is displaying here. Okay, let's see what are the tables are displaying here. How many tables are? Yeah, these are the tables. You can see here, these are the tables. So here if I take it any one of the table, so if I take it any one of the table here, so it will give the results. The size is 1K, then the record count is 0. This is not applicable. The record count is 0. The record count is 0. Nothing is there here. So you can see the record, how many records are available. You will see here. So take any one of the table actually. Okay, take any one of the tables actually. So right click and partition the table. So normally you will get the requirement so that you can just do the partition. So that it will ask the number of partitions, right? So the hash partition, you can see the partitions like so first level partition, single level partitions. So hash partition, range partition, right? So hash partition and range partition. What is this partition means? Splitting the table records into another table with the same name, but with another name. Sorry, same table with another partition, another place we are placing here, another place. So we are placing here some records we are placing here, right? So especially coming to the hash partitioning is equally distributing the load, equally distributing the records into partitions, so that equally distributing. Suppose hash partitioning means the main of the hash partitioning here equally distributing the rows. Suppose this is the your HANA database, right? In the HANA database, this is the small table here. This is the table. So this is the table. This tables you are splitting here. This table you have the okay, fine. Yeah. So first of all, I will explain the difference between each and every partition. So hash partition means hash hash, that is the preferable method, but hash partition. So hash partition is the preferable method, SAP recommended method. So hash partitioning is used to equally distribute the rows to partition for the load balancing. So equally we have to distribute the records equally we have to distribute the records. So which means in the partition, suppose we have the suppose 5, suppose like example 4 billion partitions, like 4 billion records are there, 4 billions records are there, billions, okay, 4 billions records are there in one table. So when you are doing the partitioning, it will split into the 2 billion 2 billion in the one container, one partition, and one more 2 billion in the one more container. It will split it equally, it will distribute it. It is the 5 billion and one more container, it will build it. Then here it will, so 1 billion it will be filled it out. One more billion it will be, that means equally it will distribute the load, equally distribute the records into the partitions. Equally it will distribute the partitions. If it is the 4 billion records, then suppose if you choose in the 4 billion records, but if you choose in the two partitions number of partitions equals to 2, then you have to select the column as, then click on the next button, so that see here the partitioning happened, the table has been partitioned, which means here you can see one or two partitions created, and two partitions are created here, one partition and two partitions are created, means the record count are 4 billion, 2 billion in the one partition and 2 billion in the another partition. It will be divided, it will be divided. This is the partition. This is the partition of the equally, it will distribute the records, actually equally distribute the records into partitions wise. This is the this is the partition of the hash partitioning. So any questions here, any doubts?
Sir, equally distributed means within the same database or
Within the same data,
host?
within the same database, within the database only, within the schema only, it will create the one more container, one more table, it will create it, it will distribute one more partitions, will create it, it will distribute it, same table only.
Oh, in the same table, okay, it will create the
partitions, it will create it. So same
okay.
How in the 150 square yards we are splitting the master bedroom, small bedroom, how we are doing the partition here also in the same.
Okay.
So it will create the partitions. See here, previously we don't have anything. Here two partitions are there. When the query is coming to here, it will search in this partition and in this partition. In this partition, we have the 2 billion records. It will search it out. The data exists here. Immediately it will give the response back. And one more thread, it will search here. Immediately it will give the response back to the user. So that is the reason.
Yeah. For faster retrieval, right, sir?
Yeah, faster retrieval. It's kind of speed, fast, improve the performance. So improve the performance wise, it will use it. So that's why I'm not going to explain more detail. Why? Because in the commands also we have to execute this. There is some syntax to explain it. So you will get confused. Just you can understand the partitioning, hash partitioning, round robin, and range partition. Yeah, the partitions types are there. So the range partition means, sorry, round robin. Round robin is similar to the hash partitioning only. This is equally distributing the row to the paths. But this method is required for the columns. That is the rows. This is the columns actually. This methods. So this is the actually scale out scenario. Scale out scenario means you have when you have the two hosts, that time. So it's recommended to use the. So it's recommended to use the range partitioning. So range partition is recommended to use the range partitioning. So maybe suppose like actually this confusing part, the range partitioning and the round robin, hash only simply you can understand hash partitioning, but remaining you have the two partitions, right? So hash partition, let me write it here, hash partitioning, and we have the range partition, round robin method, you know, right? Round robin method. So range partition is the value based. It will do the partitioning. Values means whatever this is the, when you are doing the partition of the hash partition, it is the, so here you need to specify then how many number of partitions you need. A small table, you can go for that too. Then here column, you need to choose the column. So column you have to choose it, you have to finish it, then that will be partitioning. But when you are choosing the, range partition, it's the values, the value ranges you need to partitioning. So which values you need to include in the which partition, and which values, what is the end value of the partition, the values you have to include it here, the values you have to provide it here, the values for this column. So from 1 to 1 billion from in this partition, maybe 2 to 2 billion in this partition, you need to exclude the 3 4. There is some calculations are there. So here we will use this calculation to do the partition of the value based. This is the value ranges, range based upon the value ranges, we will do the this partitioning. So based upon the value ranges, we will do the partitioning of the, both are same, like to here both value based. This one, most of the cases, normally when scale out scenario, we have the two hosts, right? Two hosts, one database, it will be few tables are in the primary first host and a few tables are in the secondary host. So when the query comes, it will search, right, value based. Whenever when the query coming to the, when the big queries are 10 billion 12 billions records are there in one table, that time some values are in the, some table values are in the one table, some table values are in the second table, right, second host. So that when the query comes, we have to define the value here. So that based upon that value, it will search in the, so either the host one or host two, depends upon the values, it will search it out. That is the, so that is the, that is for the, range partitioning. Range partitioning means based upon the values here, it will go and set it here. But hash partitioning is for the just columns. Whatever the columns is there, it is the column wise, just column you need to select it, which column you need to do the partitioning, then you need to filter it. But so range partitioning is for the, depends upon the values here, depends upon the values you need to do the partitioning, depends upon the values you need to do the partitioning here. That is the range partitioning. Okay, so normally typically BW systems wise they will use this range partitioning, BW systems. Why? Because the BW systems, the data is analytical data will be stored in the BW systems. So which means BW database is analytical data, which means historical last 10 years, 12 years, 14 years data will be stored into the BW systems. So as and when required, if you need the data, as and when required, you need the data, you need to pull it, right? You need to pull up data from the your BW table. If the 10 years data means the data size is very huge, 2 billions, 4 billions, maybe 10 billions, 20 billion tables. That time we can use this values range. So based on that, in which partition we have the value range. Suppose we have the in partition, we have the value range 1 to 10, 11 to 12. Then when you are writing the query 10 to 10, something like that, it will go and search in this partition on the specific partition only. So like that, so the partitions works. So just so you can simply remember, right? So value, so hash partitioning based upon the columns, and the range partitioning based upon the range partitioning is based upon the so values. Suppose one partition is 1 to 10, the range pattern simply go ahead to search the values 1 to 10 where it is available. It will go and simply search it out the value partitioning. That is the so partitioning of the so range partitioning. Range partitioning is based for the so okay. So the round robin is similar to the hash partitioning only. Both are similar to the hash partitioning only. So suppose if you go to the here, you get this partition the table, then you see here only two. Here only two you will get it out. Only two you will get it out. There is no round robin mechanism. The round robin mechanism is just for so when you click on this button, number of additional level partitioning. So then here you won't get round robin actually. Why? Because it's similar to the hash partitioning only. Similar to the hash partitioning only. Round robin is similar to hash partitioning. But so this is also it is distribution of the rows actually. That is the columns. This is the hash partitioning is distributing of the column. This is the round robin is the rows to the parts. So this method is not required to partitioning in the columns. Only if the rows, sometimes system tables has the rows to tables. You want to split the rows. That time you can use the so round robin method. Round robin method you can use it. Round robin method you can use it. So but that is not available for the column store tables. That is not available. So this is a small confusing part, but no one are going to ask you question in detailed way. Maybe they may ask you like types of partitions, three types of partition. In that, which method is the SAP recommended? Hash. Maybe they may ask you like, what is meant by hash? Hash means equally distributing the records into partitions. Equally distributing the records. Equally, it will distribute the records. Suppose this table has so two records. Suppose if I do the partitioning, not should it actually it should be select the column is the only ID, then it will equally distribute the records actually. It will distribute, but here we don't have much records. Maybe here we need to select the two partitions. You can select it and select the hash partitioning. If I click it, then it will equally distribute the records 1 to 2, something like that. It will be equally distributed. See here the two records are there. Two records, one in one partition, one record, one more partition, one record. So when you are searching here, based on the so column, it will be searching. But when it go to the range partition, it's so based upon the value, based upon the values we have, right? Suppose if you go to the each table there is some values you will get the table values. So based upon the value, you will search the records. Here we don't have much one. That's why we are not testing more on the range here. Nothing is there. There is no data here. Okay, just simply remember. So what types of partitions? There is a concept in the HANA. So you can simply distributing the partitions into smaller chunks. Chunks means smaller records, we can distribute it. For the why we are splitting means for the better results, for better performance, for the faster results for to the user. So nowadays, if the results are not getting faster, then we will get some negative feedback from the user saying that system is always slow, something like that, right? So that's the reason. That's the reason. So if the table records are very huge, even though if you split it the smaller chunks, then you will get the better results. Simply you will get the results. So that's the reason. So here while performing this one, data size is same. The only records will be split into the multiple partitions wise. It will be record will be split. So and also if you see here, there is a one more thing while we all are here. So here you can see here, you can just export the data, you can import the data, you can delete the data. Means each table data you can export it. Each table data you can export it. The table data you can export it. You can do the export option. Suppose if you see here, you want to create the new index, you can create it. If you want to delete, if you want to export, if you want to import, so all these things we can perform it. And also if you want to load into memory, unload from the memory, file from the delta merge, these three options are very important here, right? Sometimes, so delta merge we know, right? Delta merge, moving the changes for each table, there is a delta merge will happen, right? Whenever the changes are there, so delta merge means after the commit, after the transaction is committed, the data will be moved to the delta storage to main storage. Delta storage to main storage, the data will be moved. So sometimes the delta merge is not happening, then you can perform the delta merge operation also. So that after performing this delta merges, all the committed entries from the delta storage to main storage, it will be simple, right? That time manually it's performing. But so it's not the recommended approach to do. So manually you no need to do this one, force merge. Why? Because so system automatically it will initiate the smart merge. So you no need to perform it. In worst case scenario, where changes are not reflecting, you done the some payment, you done it's not reflecting into the table level, you done the some changes, it's not reflecting the table level. So you done the payment, you done the house loan payment, the loan is not reflecting here. So in this case, if you allow the system to sometimes system automatically perform the merge, right? Delta storage it will perform it, right? So the table level. But even though it's not performing, it's a very urgent. Then in this case, manually also we can perform it. Manually also we can perform the merge. Manually also we can perform the merge to the this one manually also. Suppose the table is so here you have the option load into memory, load into memory. So we already discussed this part, right? In the HANA, so we have the RAM and OS level file systems we have, right? OS level file systems means data /HANA data /data and /log folder we have. So in the SAP level, so sorry, in the RAM we have the part, we have the partitions, right? Partitions in the table level, each level we have the partition, right? This is table. Suppose like example in the table in the main memory, we have the delta storage and the main storage. Delta storage and the main storage are available here. So we can manually perform the delta merge, right? And also you can also whatever the table entries are there, you don't want that table in the main memory. Why? Because if the table is exist here, the license will be increased. So the main, because the license is based upon the main memory. Our license is based upon the main memory. Your large tables are loading into the here means your license is getting, so it's in here. This license is getting to this license usage is getting to the less, right? So very high usage is getting to the more. So that few tables you can load, reload, load, unload from main memory to data folder. Unload means so here option. So unload from main memory, which you perform this one, that will be cannot from the, you are not authorized to perform. I don't have the authorizations to perform. But the main aim is here. Unload means we can see here the actions unload the tables from main memory. The next time when the table is accessed, it will be slower because of data will have be loaded first in the memory. Depending upon the size, it will take some time. Okay, you got it right. Now what is it mean? So when you unload the table from here to here, what will happen? It may take some time. Why? Because when the when again you are fetching the table, first it will be loaded to the here, then again it will be calculations will happen. So that is the reason that will be happening. So here when you are doing the unload from main memory, which means so when unloads the table included delta merge, so including delta merge from main memory to data folder, data is like data folder, it will be because so next time this table is accessed, so one fine day you are want to access the this table data, that time it will be slower because of first it will be again it will be load to the from the here to here, then you can access the data. So load means you can load from here to here, you can load it, load to the memory. Load to the memory means there is one more option you can see here, right click and load into memory. This action is complete including the into main memory, it will be loaded to the main memory so that will be data will be faster. So normally the few customers, they will few companies, few organizations, few customers, they will plan few tables will be not used, maybe yearly once. So 6 months once they will be use the tables. In that case, entire here they should not be load the table into the here, right? Entire here they should not be load the table into here. Then we can unload it. We can unload the table here so that whatever the table size is the 4 GB, the 4 GB memory will be free here, so that your license usage also will be reduced here. That way they will plan it actually. But when the next time when they want to access the same data, the data should be loaded to the here, again they can access it. That will happen here. That is the things of the here loading and unloading concept in the here, loading and unloading concept here. Okay, and export import we discussed, deletion, data preview, the data will be deleted here, it will show it here. That is the thing. Okay, so we have a few other small topics. We have many major topics are there. The major topics means so smart data provisioning, smart data access, backups, restore, HANA, HA, system refresh. The major topics, these are the major topics, very important topics. These are the topics are pending. So that next week we will aim to complete it. Okay, so you can practice it. So whatever we have completed.
Replication will not come in this, Ravi.
Yeah, HA means replication. It will come actually. Maybe if I go HA means high availability means it's like a replication only.
Okay.
So could you please tell that provision?
Provisioning, data, smart data access, right? I mentioned the
Yeah,
provisioning. This is the one, first topic. This required some binaries to, not binaries, some configuration I have to perform it here. So if you see here, some configurations, configuring the remote data source connection to suppose like SQL server. In this case, I need to install some drivers I have to install it. So some Unix ODBC drivers I have to install it in the system. So that when we are configuring the configuration that time, so it will be connected. Otherwise, we may face the issue. So this weekend, right? So I will try to finish this one. Then when